Hey folks, I'm Saeed the Codogrammer, and in this video we're going to take a look at 3 interesting features of Java 21. Now, Java 21 was released around a month ago and it's packed full of interesting features. We're not going to cover all of them because it would take too long, and maybe that's better done in other videos. Now, Java 21 is an LTS release, which means it's probably going to be in use for quite a while and used quite a lot. It's a pretty major release in terms of the features that are in it. So let's take a look at some of those features. Let's go and start coding. All right, so here we are in the code. Now I have an IntelliJ project running Java 21 with preview features enabled. And what that really means is that new features that are being trialed in Java that aren't actually finalized, they're released as preview features, things like string templates, unnamed classes, etc. Now, if you want to try some of those features, you have to specifically enable preview by selecting it here. All right, so the first thing we're going to look at is something called sequenced collections. Now, a bunch of collections in Java define something called an encounter order for their elements. That means that if you had 3 elements, for example, 1, 2, and 3, you would expect to encounter 1, 2, and 3 in that order. Now, the list and deck collections both do this. The problem is that prior to Java 21, their common interface was collection, but collection doesn't specify the fact that they have a defined encounter order. There's nothing in here that tells you that. So if you had an interface, and an interface is how we specify contracts for things that we pass around, you don't really have an abstract way to specify that you want a collection for your method that has a specific encounter order. But thankfully, with Java 21, that's no longer the case. You have an interface called sequence collection. And just to prove that we have that, let's click on list, and we can see that it now extends sequenced collection. If we click on that and just click that one here to see what extends it, you can see there's all kinds of extensions of it: array list, array deck, blocking deck, there's others. Okay, we won't go into details about all of those for now, but suffice to say, if we come back to our code, suffice to say that now you could say anything that extends sequence collection does have a defined encounter order. So that's sequence collection. And what that allows you to do is you can have a method that says print ranked boxes in order. Okay, so the order is important and you want to be passed a collection. You don't really care if it's a deck or a list or some other kind of collection, as long as it's a sequence collection, because the order matters. Now, because such collections specify the fact that they define an encounter order, suddenly a bunch of other operations become possible. So the sequence collection interface defines a bunch of new interesting methods, which you could look at on here. I've specified a few interesting ones here. So you've got one called reversed. So given that there's an order, you can now reverse that order. You can also get the first item from the collection. You can get the last item from the collection. And if you want to add something to the beginning of the list, you can say add first. So there's more. You can have a look inside sequence collection, but hopefully that clarifies things for developers. They can see immediately that a certain collection is sequenced or not. And once they know that it is sequenced, they can rely on that and also code to that interface. All right, so next up, let's have a look at something called pattern matching. So I'll just zoom into that a little bit. So pattern matching is something that you might have already heard. It's a bit of a buzzword. Pattern matching is something that is part of something called Project Amber, which you can read more about at this link. Pattern matching in general has been slowly making its way into Java versions. Most, but not all of the pattern matching features were preview prior to Java 21, which means you have to enable preview features to be able to use them, and they're subject to change. But as of Java 21, record patterns and pattern matching for Switch is no longer preview. It's now finalized, and it's not really over yet because pattern matching will likely continue to evolve. So let's take a look at pattern matching for instance of. Now, in this method here, we've got this object O, and that's set to a string value of hello. Now, if you are inside this block, you know that O happens to be an instance of string. The compiler knows that, yet you still had to, prior to Java 21, you still had to cast the O to a string, even though it can't be anything else inside this block. Now, this is an example of pattern matching for instance of, where now you can say O instance of string, and you no longer need to cast it. You can declare the variable there, and then immediately you have access to that. So this part isn't actually new, rather it was introduced in Java 16, but I just wanted to show it to you because it comes under the banner of pattern matching. All right, so let's have a look at what's new in Java 21 for pattern matching. Well, here is a traditional switch statement, and a switch statement is something that allows you to go into a particular case depending on the value of a variable. So in this case, we've got an integer I with the value 10. Now, each case evaluates depending on the value of the integer. If the value is 10, for this case, we go into here. For the case of 20 or 30, we go into here. And if none of those values match, we go into here. Pretty straightforward. It's a traditional switch statement that matches on values. But now we can match on expressions or patterns. So imagine we've got an interface of vehicle that has a default method, just for simplicity, of get registration number, which returns blank. Not really important. Okay, and you've got 2 implementations of the vehicle interface. One is car and one is boat. They don't really do anything specific at this point, but we don't really care. It's more just for demonstration. Now let's create an instance of vehicle. That's the interface, and the implementation is a car. And if we receive a vehicle, we have a vehicle variable, and we want to do different things depending on the implementation of the vehicle or particular patterns, we can use this new syntax. So first of all, we say switch over the variable. Now imagine we've got a null scenario. Vehicle could be null. Prior to this feature, you had to check for null before your switch statement. Otherwise, you would have got a nasty null pointer exception. Now you can nicely cater for the null case by just saying case null and then doing whatever you want. All right, so next up, we're going to jump over this section. We'll come back to that, and we're going to look at pattern cases. So other pattern cases include where the vehicle happens to be a car, we want to print out A. And if it happens to be a boat, we want to print out B. But if it's a specific car, we want to check the registration number. But we might want narrower patterns, something we call a guarded case. This means that you can do a pattern match and a guard in the same case. A guard is a Boolean expression. Okay, so you can see this here is a Boolean expression. And the below when condition has to be before the general case. So if we're saying case car, but also when car registration number starts with A, that has to be before the car case, because this is a specific car scenario and this is a more generalized car scenario. So the order is important. If I try to put this before the guarded case, we see an error, okay? And the special keyword you use to do this is case with when. So you have a case where the vehicle is a car, and you're also checking this special guarded case when the registration number starts with A, then do this. So it allows you to be very, very expressive with pattern matching in these new switch statements, but in a much more elegant way using when rather than lots of conditionals. And the Boolean expression part, this part here, is known as the guard. All right, and finally, you can have the default case, and in this case, we just throw an exception. Now, it's important to note that you get an error if you don't cover all cases. Now, because we use an interface, there could, in theory, be many other implementations of a vehicle type, okay? So if we remove the default case, we will get an error saying that switch statement does not cover all possible values. If that happened to be a sealed type with a finite number of implementations, then as long as we covered those, it wouldn't necessarily need the default, but it would have to be exhausted. This idea of covering all the cases, covering all the possible scenarios is known as your switch statement being exhaustive. Now, the other thing to notice is that you don't need break statements. You're providing specific cases for specific scenarios. Therefore, you no longer need the pesky break statement. And in fact, it is a compile error. All right, so that's pretty much what I wanted to cover for pattern matching. Now let's jump on to the next feature. All right, so next up, we're going to look at something called string templates. Now, it's important to note that this is a preview feature. It's not something that you can guarantee will be there in future versions of Java. It might change. It could, in theory, be dropped altogether. So that's just something to keep in mind if you start writing lots of code with preview features. And the idea is to make interpolation easier and safer, and to build a new framework for string template processes. What does all of that really mean? So let's have a look. All right, so concatenation is something that if you've been doing Java for any length of time, you will have done lots and lots of this, where you basically join strings together, and you can do it very simply with the plus operator. So in this case, we are gluing hello with name with world, and name happens to be a variable. It's basically sticking strings together. Interpolation, on the other hand, is where we construct a string and then we are replacing values inside that. Now, this format, this doesn't actually work. I just wanted to show it as an example. It's something that you can do in quite a lot of other languages, but you see that you construct the entire string, and this value here would be replaced if you had this format of string interpolation in Java. Another example is text blocks, which you do have in Java, introduced in Java 13 as preview and formerly in Java 15. Now here you have a block of text with some format characters here. It's essentially a replacement variable, which you replace with Joe here. So you'd end up with hello world Joe, okay, printing out. Now, the big problem with this type of interpolation is something called arity issues. Now, arity issues are to do with the number of parameters. If you had specified 3 parameters, but you forgot and only passed in 2, you'd have a problem. If you passed in 2 variables, but you've only got 1 parameter, again, it looks like there's a bug in the code. Now, the IDE helps you out in this case with a warning, but it's not a compile time error, and it's very easy to get these kind of arity issues where you get the number of parameters wrong. So what do we conclude from that? Well, interpolation is easier to read than concatenation, but it can be problematic due to arity issues. It's also dangerous due to things like SQL injection. You have an innocent query that has a user entered value. The user enters something like a drop table command or something else, and your data is compromised. So you need some way of escaping or parsing the data for safety before use. But the problem with this is that safety for SQL is different to safety in your JSON, is different to correctness for HTML, etc. So in order to solve these issues, along come string template expressions and string template processors. So let's have a look at an example. You've got a variable here, string name equals Tom. And we will introduce the str processor for string templates. I can just click on that and you can see that that's available in Java Lang. And in fact, you don't even need to import this. If I go to the top here, we don't have that imported specifically. So it's available to all of your code without importing anything. And we declare it like this. So we say str dot, and then we put the speech marks there. And then we can do backslash curly braces and the name of a variable. And that now allows string interpolation. Now, inside these brackets, you can also call methods. Okay, so you can say name.toUppercase, expressions can be used, and expressions could be nested. So if you had name.last name, for example, you could do that, and then you could say toUppercase. Okay, we don't happen to have that in this case, but that's just an example. And you can also use these string templates with text blocks. Okay, so you can say str dot and then triple quotes there to declare a text block. And then text block, you've got some HTML and you want to replace the title in this case. In fact, that's a little wrong. So let's correct that. A backslash there. So you can see in this case, the value would be the HTML that we declared, but with the title value replaced with the value my page. So that's what a string template processor looks like. Now let's go a bit further and have a look. If we had, for example, something that we wanted to format. So we've got a value here of distance, okay, 21.27, whatever, miles, kilometers, whatever. And in this case, we want to have our string displaying the distance. But in that, we want to actually apply some kind of formatting rules to the value. Well, we can use another string template processor. Instead of str, we can use FMT. Now, FMT is also baked into the JDK. It's in Java util, so you do need to import it, but it's built into Java and it allows us to do formatting. So you just present the formatting characters before the variable and it goes ahead and formats it so that it would look like that. And we can give that a quick run. Yeah, you can see that it's formatted that value in the way that we've specified, okay? So just to conclude on string template processors, the template processor has the responsibility to ensure that the output is safe. So you can have different processors for different use cases. In this case, you've seen str for standard strings and you've seen FMT for some formatting, but you could have one, for example, for JSON. You could have one for SQL, one for HTML, and one for any other format that could be provided by other libraries, not necessarily the JDK. And they could perform all kinds of safety checks, escaping, format checking, etc. And so you can start to see how useful that could become when you're handling that kind of data in your applications. So really, this is early days for this feature. It's currently preview, and I would expect a lot more processes to materialize if this feature stabilizes in the not too distant future. All right, so that pretty much concludes our coding. All right, I hope that was useful. Let me know in the comments below if you think I missed anything on the features that I did cover. And if you'd like me to cover any other features of Java 21 that might be interesting, let me know. And make sure you subscribe if you don't want to miss out on other interesting tech and programming content. And thank you for watching.